Hello everyone, very good evening. Hi guys, good evening. How are you all?
Good evening, sir.
Good evening, sir.
Okay. So first of all, a very warm welcome to everyone who has joined us for this today's live session. Um, whether you're connected to Zoom or guys are tuning to YouTube live, welcome to this Tech Network family channel again. And I'm delighted that you are here for day 2 of the CCNA's 200301 training. I can see very familiar names here in the chat from yesterday, and I can also see some new participants who have joined us for the very first time. So a big shout out to all of you guys. If you're joining for the first time, so don't worry, you all are not at all late for the party. We'll make sure that you stay on track with us with today's session itself. What we had done yesterday, let me just give you a quick recap of that. Before we move ahead with today's session, we'll see what things were covered yesterday, okay? And parallelly, I'll keep on monitoring the chat also. So if there is anything, yes, please feel free to drop the things in the chat too. So in the previous session, we laid the foundation, okay, of the CCNA's course, where we discussed exactly what CCNA 200301 is and how it will help you to shape your networking career. The core topic discovered yesterday was the certification, including network fundamentals, routing, switching, security, and automation. The importance of the certification in the industry and the wide range of job opportunities that it will open up for network engineers to security specialists. That was also one thing that we have discussed. How to demand for networking professionals is increasing, and how this course will prepare you for the real world scenario. That was a thing that we have discussed yesterday. And now moving forward to today's session, we have an exciting day planned where we will be diving deeper into understanding about the network devices. What all different types of network devices do we have? What exactly is computer network? What are all the components that we'll see? Basically, the first module of your CCNA course. So get ready to take notes and participate actively here and enhance your networking knowledge along with us. Okay. And guys, one more thing, I'll again love to iterate that. See, this is an interactive session. So if you are on Zoom, feel free to raise your hand and drop your questions in the chat. If you're watching on YouTube, you can use the live chat feature there to engage with us. And we are here all together to learn, right? So without further delay, let's get started with day 2. I hope you all are excited. Yes or no?
Yes, sir.
Yes,
Okay.
sir.
So who all are here for the very first time?
I'm here for the first time, but I have bought your channel. I was looking for some documents there.
Understood. What's your name?
My name is Dinesh Rana.
Nitesh.
Dinesh.
Dinesh. Okay, welcome, Dinesh.
Thank you.
Dinesh, can I have a quick introduction of yours?
My name is Dinesh. Actually, currently I'm working with OBS, Orange Business Services in Gurgaon, and I am
Okay.
from Himachal Pradesh.
Amazing.
Yes, and my day-to-day work is to handle network in OBS department. Right. Uh, Currently, I'm looking for some changes in my skills. Like I want to promote myself in SD-WAN, but
Okay.
I'm looking to brush up my CCNA as well. So just join this course with you so that I
So,
can.
like before jumping onto SDN, you want to just brush up your all these skills,
Yes, correct.
right?
Yeah,
Exactly. So in MPLS, like there would be MPLS would be there in SD-WAN, right? Other
correct.
than
Yes.
BGP is there,
Yes,
OSI,
yes.
HERP, all such concepts are there.
Yeah,
So,
correct.
have you got chance to like work in the controller environments in the SD-WAN environment?
Not yet. Actually, we have recently OBS have recently launched a
Hmm.
project. So customer is currently we are
Hmm.
handling a customer from last 5 days. I mean a week.
Okay.
So our training needs to be done from OBS side, but still I want to upgrade my skills from my side. Not I'm not dependent on on the company side.
I appreciate your efforts, man. That's very nice. That's very nice. Congratulations, first of all, for this. That's
Thank you so
amazing.
much.
Okay, guys. So now we'll start. Okay, is there anyone else who has joined today for the very first time? Well, first of all, it was Dinesh. So welcome, Dinesh. Anyone else?
Not me, actually. My wife is also interested in this course, so we both are here to start.
So I'll welcome both of you here. Welcome to this
Thank you, sir.
today's session, guys.
Mhm.
Okay, then allow me to start. We'll start with the today's session. So I hope you guys remember what all things have we done yesterday. We were discussing about certification track, what exactly this entire certification track is all about, what are things we are going to learn in this particular course. Okay, and the first module was there, which basically tells us about different types of devices. Okay, so let me share the screen first of all. Just a second. Guys, let me know when you are able to see my screen. I hope it is visible.
Yes.
Cool. Okay. So in yesterday's module, when I was explaining the syllabus, I told you that we will explore various devices that basically form the backbone of the computer networks, right? So we are going to discuss about their purposes, functions, types, how they are interconnected to connect a seamless communication system. There is an essential topic for anyone interested in networking, whether you are beginner or advanced learner, right? So let's get started with the networking devices the very first time. Before starting with the networking devices, I'd like to introduce one more term here, which is the network. Yesterday, we got some answers from everyone available here. Connections, it was like connecting multiple devices all together. And when they tend to communicate after getting connected, that is what the network was. So, guys, computer network basically is a digital telecommunication system. This will help you to enable different devices. You can call them as nodes too, so that they can share resources and communicate. This network also helps us to connect routers, switches, firewalls, and different endpoints like PCs, servers. You can associate mobile phones also. So whenever all these devices are connected together, that is what is called as network. And then what is networking? So guys, networking is basically that method which will allow the seamless data transfer, internet access, and efficient communication along the system. That is what networking is. Here, we are looking on to the networking devices. So I'll request anyone of the attendees to just let me know. Santosh, can you please unmute yourself? Anyone who can unmute and come forward just to volunteer? Anup, would you like to come? Or Abhiram, would you like to come?
Yes.
Okay. Abhiram, presently on screen, there are 1, 2, 3, 4, 5 different devices available, right?
Okay.
Are you aware of any of these, one of these devices? What are these devices?
I'm aware of the picture that says fire symbol, firewall,
Okay.
and the first one, switch,
Okay. This is a switch. Okay.
and
It is representing a firewall in a representational manner. In
okay,
reality,
yeah.
firewall doesn't look like this, right? But this is a representation of it that we will be using in our notes to represent a firewall. Amazing.
Okay.
And here we have one more device. Can you look at what this device is?
1 second. I see load balancer.
Exactly. This is a load balancer, guys. What does a load balancer do? It will help you to ease out your load. Generally, what happens whenever we are dealing with the traffic in the environment, so traffic tends to move very quickly, right? And there is a high amount of traffic that needs to be transferred. Sometimes our communication streams get hindered due to the heavy amount of traffic, and even bottleneck can be created there. So in order to avoid the bottlenecking of the traffic, load balancers would help you to ease out your load in different segments. That is what the load balancer is all about. We'll come to see all different devices which are available in the diagram as well as in the forthcoming slides also. We'll see what all these devices are. We have already gone through the computer networks. What exactly networking? Yes, please.
I'm sorry, but the first one, is it a patch panel or a switch?
This is a switch.
The first one?
Yes.
Okay.
Okay. So now, what exactly are the networking devices? Guys, whenever you tend to connect multiple devices all together, let's say if I have let's say for a very simple example, I have 3 different devices, 3 different PCs, PC1, PC2 and PC3. If I had only 2 devices, I could have connected them via LAN cable. That would be an easier solution and a cheaper solution. But if I have multiple devices, in order to connect multiple host devices all together, I need the networking devices. Networking devices would help you to create a network and connect seamlessly all multiple devices together alongside into a network. The very first device in this segment that we will be learning in our networking scenario would be switch. So let's talk about switches for now. One of the fundamental component of your network is what we call a switch. Generally, if we talk about switches, they operate at layer 2. What is layer 2? For understanding layer 2, we'll have to jump onto the understanding of the OSI model. Yes. So let's jump quickly to see what exactly this OSI model and rest of the things are. Let me just open the whiteboard for a second.
क्या हुआ इंटरनेट गया क्या
No, I have switched to a whiteboard. It must be taking a minute to open for everyone. Is it visible now?
Yes, sir,
Yes,
it's
it is.
visible.
Okay, yeah, it generally takes some time. So from this whiteboard, whatever I'm writing down, you guys will be able to get a PDF format of this file. So that would be easy for everyone to access the notes too. Okay, let's start. So guys, we are talking about the base of the entire networking structure. That guys, please don't annotate over the screen. It would be a problem for me to like explain that. In order to zoom the screen, if you wanted to zoom out in the screen, you can just use 2 fingers from mobile, and if you are from systems, you can just scroll your mouse wheel to zoom in and zoom out. If you touch from a single finger, it will like just right over it. So please don't do it. Thank you. Okay, now we are talking about the OSI model. Generally, this OSI model is identified as a reference model. What exactly is the meaning of reference model? Reference model is something that will help you to understand the networking architecture and create your own standards to build up your communication standards. That is what OSI model or any other reference model is all about. Cisco's CCNA course tells everyone to follow the learnings of the TCP/IP model. TCP/IP model is we prefer to go through the OSI. Okay. If I talk about OSI model now, in older times when no networking devices were available in the environment, generally what was the challenge for the devices to get connected was, if I have 2 different devices which are operating different operating system. Let's say I have one Windows machine and the other one is a Linux machine. So the biggest challenge here would be both of these machines will not be able to communicate to each other because they have different communicating standards. Windows machine must be generating the traffic in ASCII codes, whereas the Linux machine must be generating the traffic in ABCD code, which means different standards of communication. So it would be very challenging for these devices to communicate all together. So just like we humans do, let's say if we had different languages or different native languages to communicate. In order to communicate with each other, we used to follow a common language, just like English is the common language for all of us. Similar manner, humans implemented the networking terminologies too. In networking domain, when different operating systems tend to communicate with each other, the solution here comes as the OSI model. Just like we human use English, networking domain devices use OSI model as a transmission medium so that they can communicate with each other. What OSI says is, it doesn't respect whether you are generating the traffic in what communicating standards. Just arrange that particular traffic in the outline which is divided or explained by the OSI model. And that would be easy for anyone to understand. In OSI model, how many layers do we have?
7.
7 layers.
7 layers. Can anyone name what those layers are?
Physical layer,
Physical layer, data link layer, network layer, transport layer, session layer, application layer, and presentation layer.
Physical layer, data link, network. I'll write in short forms. Would that be fine for you, everyone?
Yes, sir.
Transport, session, application. Oh, before application, one more layer will come, which is presentation. Presentation, and the topmost layer is the application layer. These 7 layers all together form the OSI model. Now, the networking device which we were talking about, that particular device switch operates at layer 2 of the OSI model, which is the data link layer. Here your device switch operates. Switches are of different capabilities. You might find different switches which even operate at layer 3 too. They are called as L3 switches. In the market, multi-layer switches are available. Those multi-layer switches are these only, who can operate at different layers, but they do have the feature of layer 2 functionalities. There are switches which might operate at layer 4 also. So any particular switch which operates other than layer 2 to any specific layer's functionality, that is called as the multi-layer switch. We have application, presentation, session, transport, network, data link, and physical layer. Can anyone help me with the functionalities of the application layer? What does application layer do in the most easiest language?
application layer means www.com.
So it provide interface
Yeah,
for the
Facebook.
application.
Okay, I'll expect a few more answers from everyone. Any more answers would you guys like to give for application layers working? What exactly application layer do, guys?
For user interface.
Perfect. User
Like,
interface.
yeah, like Facebook and all.
Can I change it to user interaction? Would that be a good word?
Yes, sir.
Yeah,
Yes.
right.
Okay, so user interaction is one word. I want more features. What else does an application layer do? Think of your answers. Meanwhile, I'll explain user interaction. So see, what exactly user interaction means. Suppose you have services which are directly provided to the end users. Like you have a web browser, you have email clients, right? And if you wanted to transfer the files via some applications, so their users are interacting with the applications. Those particular features or whatever protocol might be running over that particular layer, that provides that feature to the users. That's why it is called as a process of interacting with the user interaction. Any more points for it?
Authentication.
Authentication, I would not say authentication will come in application layer.
File transfer and sharing of information. Or else
Imagine you are requesting, like you are accessing a web server, okay, and you have sent some HTTP requests to the server. So what will happen in that scenario? Application layer will help you to convert your data into a standard format. So data formatting and encoding is also one feature that application layer throws to you.
Authentication and security.
Authentication, I'll come to that part. I'll come to authentication part. Facilitates protocols like DNS, SMTP, Telnet. Nice, Anup. You have given a very precise way of answer. I'll accept your answer, and I'll try to elaborate that too. So Anup said that there are some specific protocols, which basically application layer serves the cause for. Exactly. Application layer, in the most easiest way to understand, you guys can understand that application layer works for every specific requirement a user has. Let's suppose I want the files to be transferred. What protocol should I use? FTP? Yes or no? Right? FTP is a protocol that I use for file transfer. That's fine. So FTP is a protocol which is available at application layer. Let's call some other protocol of your requirement. Let's say you want your devices to be associated with the IP addresses automatically. You don't want them to be associated manually one by one to all the devices. There is a server protocol which is called as DHCP. Right? It helps you to assign IP addresses to the devices automatically. DHCP is also a protocol which is available at application layer. What else? Let's say you want to send some emails. How do we share emails to the devices? SMTP, simple mail transfer protocol. SMTP is also a feature or a protocol that is available at the application layer. So guys, just to sum up the application layer, because application layer is not the thing which we are going to focus on our course. So application layer can be summarized by understanding that it is a house for all the user required protocols. Am I clear for everyone?
yes.
Okay. So application layer is basically a house for the user required protocols. Then comes the presentation layer. Talking about presentation layer, guys, presentation layer works for the traffic's understanding in an understandable manner for the user. That means any kind of encryption, decryption mechanism. In short, and in the most easiest word terminology, you can understand presentation layer works for the multimedia sakes. The entire multimedia is available in this particular layer. Any protocol that is related to multimedia would be done here. You want to compress the images, JPG formats, PNG formats, you want the videos to be transmitted, MP4 formats, all those things would be done by the help of presentation layer. Other than presentation layer, the next layer that comes into action is the session layer. So let's assume Anup is accessing Facebook servers, okay? Anup logged into the Facebook by providing his login credentials. So if I say that at a timestamp of any specific second, it was Anup who was accessing the server. So is it only Anup who would be accessing Facebook server at the single instance? No, definitely no. Ultimately, at a single moment, million or billion of the users are accessing Facebook, Instagram, Snapchat, any specific server that you can take into consideration. So how do these particular servers identify that, okay, fine, these login credentials have to be associated to Anup only. Anup is requesting something, so I'll help Anup only to understand those or transfer those informations to Anup. What if Anup has opened multiple tabs in his web browser? How will those sessions be bifurcated? Session layer is responsible for maintenance of individual sessions between the user and the servers or any particular communicating entity in your environment. So one single word that you can remember for session would be session segregation. It helps you to segregate the sessions. Okay. And guys, being a technical session, still I'm just skipping these layers so quickly. The reason is the experts who operate over to these particular layers, they are called as the application developers, web developers, and the software developers. we network engineers come into action from this particular heart of the OSI model, which is the transport layer. So this is where from we start to get into the action, the transport layer. If I talk about transport layer, what do you guys think transport layer works for? As the name suggests, transport. It helps you to transmit or transport your traffic informations from one location to another location. Just assume the way we shift our houses, okay? So anything which is available in your house, all of your luggage, every particular belonging of yours, that is basically the data that has been generated from the topmost layers, application, presentation, and the session that the developers have generated in form of user data. Now this data needs to be transmitted. So this data has to be packed up in different boxes and have to be arranged in a vehicle so that it can be transmitted to the destination. So at the source location, transport layer comes into action and takes the responsibility of packing up these data. So this user data would be handed over to the transport layer. Now, transport layer have two specific truck drivers. One is TCP, very responsible driver, never drinks, never smokes, drives very carefully. So this is TCP, Mr. TCP. Another driver we do have is Mr. UDP, full on drunkard. You cannot trust on his driving. Drives very fast, drives very carelessly. Your luggage can fall anywhere. You cannot rely on him. That is the reason why technically we speak of TCP as a reliable protocol. Whereas UDP, it is considered as an unreliable protocol. Now I have a question for everyone. Should I ask? Yes, no? Guys,
Yes,
tell me one.
sir.
Yes,
What
go
do
ahead.
you guys mean by reliability? Reliability means trust. Someone you can believe on. If you say that, okay, fine, Aryan is a reliable person. So that means you are trusting on Aryan, right?
Yes.
So in our communication, why would we trust on any entity which is not reliable? Why would we even use it? Do any one of you have any answer for this? We are working over the communication or transmission of the traffic, right? And for many companies, for every particular organization, their data or their communication is of crucial important, right? So how come anyone would like to go for an unreliable means of source to communicate? Yes, one answer would be speed, correct? It would be speedy. It would be a faster transmission. Any other answer to that? Flow control. Okay. Flow control is available for both the cases, whether it is TCP or UDP. We have flow control for both of them. I need one more answer, just one more. Streaming services. Cool. Yeah, you gave my answer. Amazing. Let's start it from against this scratch the explanation. So guys, this transport layer is responsible for end-to-end communication. It will take care of your data flow. It will take care of handling the errors, whatever error happen in the transmission, and even the very first feature, which is the segmentation of your traffic. Generally what happens, whenever the user data is handed over to the transport layer, the first priority of transport layer is to break down this entire data into smaller parts. So transport layer chops up your entire data into smaller parts, and these smaller parts of your traffic are identified as the segments of traffic. Segment is basically the PDU for transport layer. What is PDU? Guys, what is PDU? PDU stands for protocol data unit. Similarly, whenever we are mentioning or referring to a distance, or let's say to the weight, for weights we refer a unit which is grams. Correct me if I'm wrong. Grams, pounds, that is a unit for weight. If I'm calculating height, so we might go for inches or feet. Similarly, guys, please don't scroll like this. It would be very challenging for me to navigate back there. Just a second. Okay, no worries. Just a second. Yeah. So we were discussing about TCP and UDP, their reliability and unreliability. So Anup has answered that, sir, it is for streaming services and it is speed. That's why an unreliable source of communication can be used as a medium. Definitely. Generally, what happens whenever you're transmitting the traffic has to be segregated into two different parts. And that is how TCP and UDP come into action. Generally, TCP is used for such applications where you want to share the files. Any particular case where you want to share your file, you wanted to download a file. In such cases, TCP comes into action. Let's assume, how many of you have used torrent? Anyone? Torrent services previously? Any pirated game you want to download, any pirated movie you wanted to download. Previously, torrent was a service which was available for everyone to do those things. So now just assume a torrent download case scenario. You're downloading an 80 GB of, let's say, God of War game. Okay. And when you are downloading it, the seeding and the downloading reached on to 99%. Just as your downloading reached on to 99%, your internet got dropped. And it was not available for, let's say, coming 5 minutes. After 5 minutes, when your internet came back again, your connection came back up again, what would you think? What would you say for your downloading? Would it start from 99 itself, or would it start again from 0? If it would start from 0, definitely I'll be very pissed off. But generally what happens, as TCP is a reliable source of communication or a reliable medium of communication, TCP gives you that reliability. TCP gives you the reliability that even if your connection drops and 99% of your download has been done, don't worry, your download will start from that only, and only 1% of the rest of the part would have to be downloaded. You don't have to restart back your communication or standard from 0. That is the reliable feature which TCP gives. And to give that reliability, TCP uses a functionality which is called as acknowledgement. Guys, I hope the pace is good. I'm not going way too fast. So TCP is using acknowledgement, which gives you a reliable feel while communications. Now let's take an understanding of UDP. How many of you watch a live stream? Any YouTuber you might be watching, you must be watching our live streams. Presently, our live stream is going on, right? So let's consider our live stream only, right? So presently, I'm sitting here in front of my camera or my laptop. Along with my laptop, my mic is also connected. So with this mic, I'm speaking, and this mic is catching my voice and transmitting this to the YouTube servers from where you guys are watching it presently right now. There must be some delay, at least 15 or 20 seconds of delay in the live stream, but yes, you guys are catching it out completely. Now assume while I was recording this session or like streaming this session, again the internet came down for a minute. And then after a minute of downtime, it again went back up. This is a hardware device which was capturing my audio, my screen sharing, everything. What do you think when the internet goes down? I was still speaking because I was not aware, because I was not monitoring my connection, right? So I was unaware of this downtime. I kept on speaking for another this downtime minute. Would any of my viewers will be able to see or understand or listen whatever I spoke between this 1 minute? Will it be possible for anyone to understand or even listen to?
No.
No. Why? Because the connection went down, right? Streaming service is a faster way of communication where everything which I'm uttering out right now from my mouth has to be delivered to your end very quickly. And once the connection went down, streaming service cannot work. This is the case where UDP works. Let's understand it in a more easier way. We started this session today at 7 p.m. right, in Indian timings. Presently it is 7:37. I have delivered this session for past 37 minutes, right? If I say that for the past 37 minutes, I was like transferring the 100% of my communication data. Is anyone available here who can speak just the same thing in the same sequence, in the same manner, just as I have delivered? Is there anyone who can do this? Yes or no? I feel that is not possible. Someone needs really a superhuman capability to do so, like to just repeat the same sequence of the words and terminologies just as I explained. So what is happening here? You are not able to explain it out, but for these past 37 minutes, whatever I was explaining, were you guys able to understand it? Was I able to express my feelings and my words to you guys? Were you able to understand it or not? Yes or no? Yes? Right. Guys, this is the same reflection what UDP does. UDP is used for such scenarios where you want the faster transmission of your traffic, faster delivery. But will the delivery be completely of the entire traffic? That cannot be a surety here. That means you cannot be sure of full delivery. Your traffic will be delivered very quickly, but complete delivery is not a case here. Whereas if I talk about TCP, the file downloading scenario, if you're uploading a file to the server, it completely depends upon your bandwidth, that how long it will take to upload. But even if I have a 10 Mbps of connection and I want to upload a 800 GB of file to my server, I'm pretty sure that this 800 GB of the information will definitely get uploaded, whether it takes 4 hours to 6 hours of time, whatever, and that particular time duration will completely depend upon my bandwidth. But there is a surety that yes, 100% of my traffic will be delivered to the destination. So here, the transmission time is slower as comparison to UDP. But yes, here we have 100% short delivery case, that my traffic would be delivered to the destination completely. This is the difference between TCP and UDP. Talking about TCP and UDP's working scenario, whenever any particular traffic flows through TCP or UDP protocol, they basically refer to the port numbers. We have an entire range of 16 bits of port numbers. What does 16-bit means here? Bit means binary values, a combination of 0 and 1. That means total, how many values we do have? 2 values. So a possible combination of these particular 2 values, that means 16 possible combination of such values, is what 216-bit means. So if I'm saying the port number is of 16 bits, that means 2 raised to power 16, which comes out as 65,536. That means all total we have these many numbers of port available in the environment. And every port is associated to an individual application, which is predefined. Talking about these port numbers, they are being bifurcated into different categories. One is called as the well-known port numbers, which has a range from 0 to 1023. Then we have registered port numbers. Registered port numbers start from a range of 1024 and they end up at 49151. Rest are called as the ephemeral ports or the random port numbers, which are used for the random applications. For temporary use cases, those ranges for the random port numbers or dynamic ports, that is from 49152, and it ends up at 65535. So these 65,536 ports are categorized in these three different variations. Well-known ports consider all those protocols that you are aware of, DHCP, FTP, all those different protocols. Registered protocols are those protocols which are interiorly developed by some organization for their personal use cases. So they used to get reserved within the registered port range. There is an entity, guys, who does all this case. That entity is called as INA. If you want to learn more about it, you can simply go onto your web browser and type ina.org. It is an organization that works for all such cases of the assignments. Who all of you have ever visited to this previously? Anyone? They are responsible for domain assignments, protocol assignments, IP address assignments, as well as the protocol or the port number assignments. The best way to see all the particular port assignments, I would rather refer the Wikipedia, because there is a specific list available. List of TCP and UDP ports. Just search this over Google. You'll get a Wikipedia list here. It will show all the present protocol sequences, every individual protocol which is available in the environment. You can see TCP and UDP. There are few protocols which uses both TCP and UDP, but there are some protocols which individually use TCP or UDP. Just like, let's say we go for port number 67 and 68, right? So it is DHCP protocol. It uses UDP protocol. DHCP uses UDP at layer 4. If we go further ahead, let's take HTTP. HTTP is one of the case of protocol which uses both TCP as well as UDP. So you can see this entire sequence, it will end up at 1023. After that starts the registered ports. So they are assigned by INA. Can you see? The entity's name is referred to here. Internet Assigned Number Authority, which is an organization oversees all the global inflections of IP addresses, port numbers, autonomous system numbers, every particular thing. So you guys can go for this particular link. I'm dropping this particular link in the chat. If you guys want to bookmark, you can just bookmark this particular thing. I've dropped a link in the chat. You guys can refer to this particular thing whenever you're revising the course. You can go through this particular thing to understand about the port numbers. Let's move ahead then. Any questions so far? Hello? Guys, hope I'm audible. No question for Anu. Anyone else? Guys? Prateek, Mehul, Abhiram, Dinesh, Leap, Harsh, any question? We are good so far. Shall we move ahead?
Yeah.
Okay. So what we saw here was OSI's application layer, presentation layer, session layer. Here, the traffic which was being generated was identified as data. Data is basically the PDU for all these layers. PDU means protocol data unit. Once this data comes down to the transport layer, it gets broken down into smaller pieces, which is called as segments. So segment is a PDU for layer 4 or transport layer. Then this segment needs to be transmitted from one location to another location. And location can only be identified by an address. Okay, there's one question from Purushottam. I want to ask external questions. So are you sharing screen, Zoom, and my device? Let's stop here. No, I have just shared the whiteboard presently. Purushottam, nothing else. Purushottam, I hope you are able to see whiteboard.
Actually, when I had the same question, like I thought you were sharing the screen, but no, it's only the whiteboard.
Yeah, it's the whiteboard only. No, it's not there. I just navigated over to Wikipedia just to take out that link for you guys. Don't worry. Okay. Now, let me just check once. Let me just check.
I thought of the same, but I just zoomed in, so I was able to see the whiteboard.
Okay, actually what happens is whenever this whiteboard will be opened for you guys can also interact in this whiteboard. From tomorrow onwards, I'll try to like prohibit that feature, but today it is accessible to everyone to like draw on the whiteboard. So if you pinch out or pinch in, so it will get zoomed out and zoom in. So that could be an issue for today. Okay, it's not visible to anyone. Okay, just give me a second, guys. I'll just cross check for once. Just a second. I hope the screen is visible now. Whiteboard must be visible for everyone.
Yes.
Yes, yes.
Okay. So if any one of you have missed what I explained previously, it was just the port numbers. I told you about TCP and UDP protocols. They utilize the port numbers for the identification of the applications. These port numbers are of 16-bit and they are arranged into 3 different categories: well-known ports, ports, and the dynamic ports or the random ports. Some people even refer it as ephemeral ports. The range in which varies for them is from 0 to 1023. You just have to identify what ranges they have. You don't have to remember specifically every individual applications or protocols port number. Generally what happens whenever we are operating or we are learning throughout the process, these port numbers automatically we will like remember or memorize them in our minds, right? So 1023 is the range for well-known ports. Registered port starts from 1024 and end up at 49151. Then comes the dynamic port numbers, which starts from 49152 and ends up at 65535. So what is happening is, in the OSI layer, from application, presentation, and session, they combinedly create the traffic information, which is called as the data. This data is then further streamlined down to the layer, to the transport layer. Once it is handed over to the transport layer, the process of segmentation breaks down your traffic into smaller chunks, which is called as the segment, which is the PDU for layer 4 or your transport layer. This segment needs to be transmitted from one location to another location, for which we use addressing mechanism, just like we humans use our house addresses. I might reside in sector 1, one of you are residing in sector 4. So these particular addresses in the globe location, they are identified as our house addresses. Similarly, where a device is located in the internet, for that, network layer is responsible to identify its logical address. And those network informations are associated over to the segments in form of packets. So the PDU for network layer would be packet. This packet can be either a IPv4 packet or IPv6 packet. Similarly, segments can be of two variants. It could be a TCP segment or a UDP segment. If you are sending any request, it could be an HTTP request, HTTP data, FTP data, SMTP data. These are the terms that we use to refer the traffic as. So once the segments are broken down and sent towards the network layer for the identification of the location, they are associated in form of IP packets. IP is the protocol that operates over to the network layer. If I talk about IP, the Internet Protocol, it is available in two different versions. One is version 4. Another one is version 6. IP version 4 is something which is represented in 32 bits, whereas IP version 6 is represented in 128 bits. Again, the same thing. Bit is what? Binary numbers, possible two combinations. So 32 possible combinations of these particular binary bits is what we call as an IP version 4 address, whereas 128 possible combinations is called as IP version 6. Version 4 and version 6, they both are responsible for the logical addressing of the mechanisms. That's why we call them as logical addressing. Again, in a specific location, it is a possibility that there must be multiple members residing within a house. Similarly, in a network, within a single network, there could be multiple hosts available at a single location, at a single network. So how can I individually identify any specific host? For that, the downline layer, data link layer, comes into action. The PDU for data link layer is frame, and the most dominant technology available in the environment today is Ethernet. So you must be identifying the Ethernet frames available in the data link layer. So here, the protocol that operates would be the MAC address for the physical addressing of the traffic. So at an individual location, to uniquely identify any particular device, you will utilize the MAC addresses of the devices, which are generally hard-coded. They are hard-coded over to your physical network interface card, the NIC, wireless NIC or the physical NIC. And MAC address is of 48 bits, which is generally represented in hexadecimal notations. So if you tend to identify a MAC address, generally it is represented either in pair of 2 hexadecimal digits or a combination of 4 hexadecimal digits is also one way of representing the MAC addresses. It completely depends upon the platform. Different platforms refer different ways of representing these particular things. How can I identify my MAC address of the device? So I'll quickly jump onto my run window. I'll open up my command prompt. Over to my command prompt, I'll simply type ipconfig /all. What does this command does, guys? This command will specify all your available adapter informations, network adapter informations. I do have my Bluetooth adapter. I have the Wi-Fi adapter through which I have presently connected. Then we have the LAN adapters available. Physical adapters are available, but presently I'm connected to internet via my Wi-Fi adapter. Physical address is what the MAC address specifies. You can see here, this is my physical address. I'll just copy it by right-clicking on it, and I'll paste it here. I'll tell you why I have pasted it here. Now, the initial 6 hexadecimal digits of your MAC address, they are identified as the OUI. OUI stands for Organizational Unique Identifier, which basically identifies who is the manufacturer of your NIC. And rest of these particular 6 hexadecimal digits, they are unique to your host device. That is why a MAC address is identified as a unique address. So as I have taken out my MAC address from the previous search of my run window, and I've pasted it in my search bar. After pasting the initial 6 digits of my MAC address, I'll simply type manufacturer. Once I hit enter, it will show me few web addresses. I'll just open any of the MAC address identifier here, and you can see this particular address was manufactured by Intel Corporation. That means my NIC is manufactured by Intel. Similarly, you can identify different manufacturers for your NICs. That is why these MAC addresses are used. So what is happening here is your traffic has been framed down from packets to frames, where your MAC address informations are associated to your frame. Now the task of physical layer comes into action. So what this physical layer will do is, this physical layer will convert your traffic into binary informations. The PDU here is bits, binary bits, in signals forms, electrical signals, light signals, radio frequency signals, and then your traffic would be transmitted from physical layer to the receiver side. So what we have navigated till so far here in the OSI model, that was basically the sender side. Similarly, the layer would be operating at the receiver side too. So I'm sitting at the sender side, and from the start of the session, we were just sending out the traffic for our understanding. So we have framed it down from data to segment to packet to frame to binary bits. Now let's assume if I have connected via LAN cable, my traffic would transmit in forms of signals and will receive towards the physical layer of my receiver. Then what receiver is going to do? Receiver will unwrap those informations at every individual layer. So now these signals will be converted back into the form of the frames. And in the form of frame, the source and destination MAC address would be identified. Then rest of the information would be handed over to the network layer in form of packets. In network layer, any specific device operating at the network layer will reveal that packet, identify the source and destination IP address. Then the information would be handed over through the transport layer in form of segments. Segments, there you will identify what protocol it is for. So source port and destination port numbers would be unveiled here. Then rest of the traffic would be transmitted to the upper layers, and in that way your request would be sent towards the receiver in form of the data. So whenever you are working at the sender's end, you are basically encapsulating the traffic, and the process is called as encapsulation. But whenever we are sitting at the receiver's end and we are receiving a traffic, the process is just from down to up, which is called as decapsulation of traffic. So encapsulation and decapsulation are a two-way in-hand process. If you are at the sender's end, you will always encapsulate the traffic. If you are at the receiver's end, you'll always decapsulate the traffic. And that is how these layers combinedly work all together. This was the explanation for the OSI model. But what happens is, I told you that Cisco recommends CCNA candidates to follow the TCP/IP model. So what is the difference between TCP/IP and OSI? There is no difference, just the layers have been combined all together. The top three layers, application, presentation, and session, are combinedly identified in the TCP/IP model as the application layer. They did much part for the transport layer. Transport layer is placed as it is with the name of transport in the TCP/IP model. Network layer has got a new name, which is internet, and placed into the TCP/IP model. Now it depends upon different references. There are some books where the last two layers are combinedly called as network access layer. Some call them as link layer. So there are two names for it. One name is network access, or another name is link layer, which is a combination of data link and physical altogether. This is called as the TCP/IP model. But yes, there is one other catch, guys. This is the representation of 4-layered TCP/IP model. We do have a 5-layered TCP/IP model where data link and physical are placed with the same name. So TCP/IP model is of two variants: 5-layered TCP/IP model and 4-layered TCP/IP model. Throughout your CCNA course, the working or the learnings that you guys will be doing would be of the 5-layered TCP/IP model, where physical and data link layer are bifurcated. I hope this relevance between OSI and TCP/IP is clear for everyone. Yes or no? Guys, I hope this is clear.
Yes.
Okay. So any questions so far? Okay, no questions. That's fine. Let's move on to the slides and look back what all things we do have to cover. Okay, yeah. So now let's come back to switch. That is how we can understand now. So as we are done with the OSI model, and now if I say that switch is a device that operates at layer 2, I hope you all are able to understand what layer 2 exactly means now. Right? So switch is something which will be operating over to the frames, which will forward your local traffic within the LAN network. Major functionalities of the switches involve sending the frames. What is frame? It is the PDU for switch or for layer 2. And frames are sent on the basis of what? MAC addresses, which is a protocol which is used within the particular layer. We would even understand and learn about the segmentation, the VLAN segmentation, when we will learn about the switches. Today's topic was only the OSI model. We'll learn about VLAN segmentations. We'll even see how MAC address table is created, because just in order to transmit any traffic within the LAN environment, switches work very frequently and very fast, very quick. So for the quicker performance, they need to maintain a MAC address table of their own. That also we will see when we will start learning about the switches. There is one more protocol that is the enemy of the network engineers: loops. So in order to avoid these loops, we have a handy protocol available which is called as parent tree protocol. There would be some cases where you would like to club multiple links all together into an individual logical link. That particular mechanism is called as link aggregation. So port aggregation or link aggregation is also a mechanism, but when Cisco implemented this particular mechanism, they identified it as Ether channel. Ether channel is a name given to the port aggregation mechanism by Cisco. Switches, they are of two different types for our learning methodology in CCNA. One is a layer 2 switch, another one is a layer 3 switch. So layer 2 and layer 3 switches completely depend upon the working of the layers. Layer 2 switches only serve the cause to the data link layer, whereas layer 3 switch will also serve the cause to the network layer by performing IP routing, which is one of the key feature of the network layer. So I hope a basic explanation of switch is clear for everyone, what exactly a switch is. We will learn again when we'll go completely towards module 2. That is completely about switches only. So we'll again get to see what exactly a switch is and what are the core working methodologies of the switch. Here in the image, what you guys are looking onto, the Catalyst 9200 and Catalyst 9500 series switches, these are the example of enterprise grade switches, which are commonly used for the networking infrastructures. This particular diagram is basically an example, guys, which tells you about the network topology, where switches are connected. Here, what has been done is switches are connected via cable here. Okay, and even these switches are even connecting multiple endpoints like PCs and laptops all together, so that they can form up a LAN network, the local area network. Switches generally create these kind of efficient communications within the organizations so that they can ensure data is transmitted only where it is needed. And that's how the traffic congestion is reduced. We'll look on to one more device here, the another device, which is a router. Now, if you see onto this particular purpose, what is written over to the purpose of a router, what exactly the router does? Routers, they are forwarding data packets. Can you see? Now we are calling it as a packet. We won't say data frames. If you are referring to data frame, then you are referring to data link layer, layer 2. But if you say data packet, that means you are referring to layer 3, IP. So data packets are forwarded between different networks. Let's suppose I am sitting in network A, and I have to transmit a communication to any particular device which is residing in network B. So routers would be responsible for transmitting that particular communication from one network to another network. And for that, they basically use the IP routing feature. So ultimately, routers are the devices which perform the inter-network communications. Some more features of routers involve routing. Other than routing, packet filtering is also one of the coolest features that routers do, which basically gives you a sense of the firewall. You must be aware of firewalls, right? Firewalls, we generally create some rules there in inbound and outbound rules, which basically let you handle the traffic flow. Similar feature, a security feature just like that has been implemented into the routers too, where you can filter the traffic on the basis of the ACLs, the rule building mechanisms. We do have NAT here. NAT is basically a translation mechanism. Generally, what happens, we know that every particular human uses IP addresses, right? And IP address is something which, if you want to access the internet, you'll have to pay a cost. But yes, the above organizations have taken care of the user's pocket too. They have provided the private IP addresses too. So what you can do is basically in your LAN environment, you implement the private address scenarios, and whenever you want to access the internet, you'll get associated to a public IP. Multiple private IPs can be associated to a single public IP, to multiple public IPs. So there are multiple ways of translating the IP addresses into single, multiple, or all IP addresses. That is a mechanism which is called as NAT. We do have different routing protocols that operate over to the routers, with the help of which it would become very easy for the traffic to navigate through the environment of the entire large wide web and reach on to the destinations. Routers also, guys, there are two different types of routers, core routers and the edge routers. Some routers which are placed at the backbone of the network so that they can handle heavy amount of traffic thrown at the devices, that is taken care by the core routers, whereas edge routers are positioned as the edge of the network, which will only connect one side to the external internet and rest would be connected towards your LAN environment. Onto the screen, we have integrated service routers, ISR 1000 and ISR 400. This is a topology which shows you how exactly a router will work. Such a nice topology. See, switches, they were connecting all your LAN devices, LAN environment host devices together. Now, these devices, if you want to access the internet, the switch would be connected to the router, and router's one interface would be connected to the internet environment so that your traffic can get out of your network and reach onto the internet and to any particular device. We do have hubs too. Generally, what happened initially, I'm talking about a very initial phase. This topology would help you to understand what I'm talking about. Let's assume I have 4 devices, an environment when no networking device was available in the market. So those times, devices were connected somewhat like this. I'm representing a bus topology. So what happened in this scenario was, when devices were connected all together like this, the medium or the cable which was used, this was a copper cable, guys. And we all have studied science. Okay, those who are not from the science background, I'll help you guys. Copper basically is a metal, and this metal is a very good conductor of heat and electricity. It conducts heat as well as electricity too. So that means if you are plugging in the current flow, it will sustain it out. It will transmit that current to the other end. Here we are discussing about data traffic. So heat is not a case to be studied. We'll understand it in terms of electricity only, because your data is transmitted in form of electricity. I'm showing you a single cable segment, a copper cable segment. Okay. Now guys, tell me one thing. Normally what happens if I flow current from both the ends? What will happen to this cable? If a current is flown from both the ends, what will happen with the cable?
It will burn.
Now we are going on to physics also. Yes, please. You guys can unmute and talk. Please say. What will happen if someone flows current? Yes, Purushottam, please speak.
I just asked, can you please repeat?
So I'm asking that this particular diagram is of a cable segment, copper cable, okay? And what I did was, I transmitted current from both the end. Current is flown from here also, and current is flown from here also. So what will happen with this?
Will it burn or heat it up like some?
Collision,
so generally,
collision will take place.
In terms of data, collision will happen, but in terms of current, if the current is of very high flow, generally what happens, cable will lose its resistance and will start to burn, right? In easiest terminology, just for everyone to understand other than the engineering background, if I'm flowing the current, short circuit will happen. Correct? In the most easiest way, short circuit will be there. But we are talking about data transmission in the devices. So data is never transmitted in that high voltage of electricity. It is a very low voltage, right? So what will happen if you're transmitting data from both the ends? Your data will lose. It will exhibit data loss. That is why the transmission with the copper cables in the computer environment is tend or identified to be a half duplex mode of communication. Now comes another new term for us to understand, duplex. So what happens is, guys, there are different modes of communication. First mode of communication which is taught is called as simplex communication. So in some communication standards, what happens? There is a device which transmits the traffic to other device. So in simplex communications, one device will always be a sender, other device will always be a receiver. One-way communication. Simplex is a one-way communication. Just like our television. Channels are broadcasting their informations over to the TV channels, and we viewers can only watch it as an audience. We cannot interact with what is going on in the movie or what is going on in the TV serials or daily soaps. We cannot interact with it. We can only cry if Meher dies, right? This is what happens mostly in the TV scenarios. That is called as simplex communication. Second mode of communication, which I explained for the copper cables, which was even a challenge for the networking environment, is the half duplex mode of communication. So what happens in half duplex communication? Both the devices can behave as a sender or receiver, but one at a time. The most coolest example for this is generally the walkie-talkie that we used to play in our childhood. What happens in the walkie-talkies? You press a button, you speak out something, other person will hear it out. Then once you are done speaking, he will press the button, he'll speak, and you'll have to listen. At the same time, both of you guys cannot speak and communicate to each other. That is what is called as half duplex communication. That means at a single time, only one device can transmit the data. But what we humans prefer the communications to be the standard and the most coolest way of communication would be full duplex communication. What happens in full duplex communication? Both the devices can behave as sender or receiver, and yes, they can transmit the traffic simultaneously at the same time. That is called as full duplex communication, what we prefer nowadays. And this is the most efficient way of communication, simultaneous communication. So in this particular diagram or the topology that I have drawn here, what is happening is we don't have any networking device available. So sadly, what we'll have to do is we'll have to use these copper cables as the communication media. These cables were called as coaxial cables. The disc cable that we use, that black colored cable within which the copper element is there in the connections. So these coaxial cables behave for half duplex communication. Now assume a scenario where PC1 wants to communicate to PC3, but at the same time PC4 also wanted to communicate to PC2. What will happen? Data loss, data collision. So in order to mitigate this particular thing, networking entities developed a protocol which was called as CSMACD, the standard protocol for wired communications. Guys, CSMACD stands for carrier sense multiple access. With collision detection. So now what happened when I faced a challenge that, okay, fine, at the same time, two devices cannot communicate because data collision will happen. So entities developed CSMACD protocol and installed those protocols over to the host devices. So now what will happen whenever there is a collision, devices will identify that collision has happened. How is it done? Again, the same scenario, PC1 wanted to communicate to PC3 and PC4 wanted to communicate to PC2. Collision happened. Now, being CSMACD enabled as a protocol for the devices, once a collision occurs, the jamming signal would be advertised throughout your network. What will be advertised? A jamming signal. Now, what will this jamming signal do? It will stop. It will ask these two transmitting devices to stop and wait for a random amount of time. Let's suppose PC1 waited for 4 seconds and PC4 waited for 8 seconds. So once this 4-second timer ends, 4, 3, 2, 1, 0, PC1 will transmit a traffic and it will be done transmitting. Meanwhile, when PC1 transmitted the traffic, PC4's timer would have reduced to 5 seconds. Now again, its timer will again reduce 4, 3, 2, 1, 0. Once that time is reduced, PC4 will also transmit the traffic. But what if the case is when PC4 was about to transmit the traffic at 0 timestamp, again PC3 wanted to communicate to PC2, again collision will happen. So although the expert's purpose of defining CSMA CD protocol was to mitigate the collisions, but it never mitigated. It only created problem. It only generated the wait time. It expanded the wait time for the users. So ultimately, it was not able to solve the solution. That is when our first networking device, hub, was developed. So with the hub, what you can do is you can connect all devices into a single network segment like this. But generally what happens whenever you are doing any technical upgrade or technical advancement, the drawbacks of the previous technology also come along with that particular thing. So ultimately, although hubs were developed in a very positive manner, but they were not able to solve the collision issues because they were operating at layer 1. That means binary level, only electrical signals. So electrical signals cannot be identified where to send it or not. So ultimately what happens whenever you want to transmit the traffic, it will be broadcasted. What do you mean by broadcast? There are different modes of types of messages. One way of messaging is called as unicast. So in unicast, what happens? I am communicating with Anup individually. No one else is able to hear it. That will call as unicast communication, one-to-one communication. Then comes multicast communication. So in multicast, what happens? I will communicate to a group. Let's say I combined myself, Orvesh, Anup. We three are communicating out of the entire Zoom meeting. So that would be considered as a one-to-group communication, which is called as the multicast communication. Then comes broadcast communication, which I'm presently doing with all you guys in this particular Zoom meeting. All of you attendees are able to hear, able to see my screen, able to interact with me. That is called as a broadcast communication, which is one-to-all communication. So hubs provided a solution by getting into the networking domain as a first networking device, but the problem was they were broadcasting every traffic, which was still a challenge. And that is when the switches were developed. Before switches, bridges were there as a device, but the upgraded version of bridge is what is called a switch that we study in our CCNA course. So hub is one of those particular devices, which was the very first networking device implemented for the LAN network communications to ease out the challenges of the collisions. So I hope you guys are clear with the 3-layer devices. At physical layer, which device operates? Hub. At data link layer, which device will operate? Switch. And at network layer, which device will operate? A router. Hubs will deal the traffic in form of binary bits information, electrical signals. Switches will deal the traffic in form of frames, Ethernet frames. Routers will deal the traffic in form of packets, IPv4 or IPv6 packets. I hope this much is understandable for everyone. Can you guys just remember this much part?
Yes, sir.
We have still more devices to discuss, but I like to carry forward those particular things for tomorrow's session. And from tomorrow onwards, we'll start learning the transport layer at the core level. That means I'll explain TCP, UDP, its different functionalities. Today's session was just an overview of the OSI model. I hope you guys were able to recall what OSI model is, what exactly encapsulation, decapsulation means, and what are the PDUs. Can you remember these 3 points? Yes or no?
Yes, sir.
Is there anyone whose answer is no? Feel free to ask, tell it out. Okay, I'm getting everyone's yes, 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 yes. Okay, amazing. So guys, from every particular session's delivery which I'm giving, I just need you to take away 30% of that particular day. If you're able to recall 30% of what has been discussed in this session, it would be enough for me to carry forward and finish up your session along with me to cover up the entire course. And even you will be able to summarize everything and combine everything in form of 100% knowledge once the session ends. Okay, so every day if you're taking away 30% of my delivery, it is more than enough for me.
Get an study materials for this?
Yeah, you will be getting the study materials. No worries.
Okay, thank you.
Study materials, lab files, everything would be given to you. Okay. So this first week that we are going for, like the coming total 6 days, presently today was the first day, right? Coming more 5 days, the next 5 days of the session, we will be covering the basics, which would be theoretical part. And I believe some of you might get bored due to the theoretical learnings, but remember, this is just the base that we are creating for understanding the terms that we might encounter in the further sessions. Okay, so I'll expect you all to bear with me just for 5 more days, and then we'll get on to the lab parts, the practical learning experiences that will start.
I wanted to ask one question, and
Yes, Mehul, feel free.
At what stage can we confidently get book the exam for the CCNA?
See, if you are going for the CCNA exam, I'll suggest you, first of all, let's finish this course. Okay, after that, revise everything for 15 days, because the structure that I'll guide you for your exam preparation, we are going for the exam preparation also from this course. Means this course is not only for interview takers, it is for exam appearers also. It is for the people who want to excel in their roles, for job promotions, for everything this particular course would be. So I'll help you guys by explaining what types of questions come in the exam, how those questions have to be cracked within seconds or within minutes, because some questions generally takes a minute or two also. Generally what happens in your 2 hours of the exam, there would be more than 100 to 120 questions. Okay, sometimes 75, sometimes 90, sometimes 120. The number of the questions completely varies month to month of the exam, as it is a global exam. So in every 3 months, I think the exam changes. Okay, so I'll help you with developing of the techniques to solve the question, to identify the specific section of the multiple lined questions where you have to focus on what exactly is being asked in the question. Generally what happens, Cisco loves to play with the terminology. Cisco loves to play in the grammatical flow of the questions. So that is something which we'll try to crack. And once that is done, so after training ends, 15 days of revision, and then you will be good to go for the CCNA exam. I hope it was clear, Mehul.
Yeah, it is clear. Perfect. And when did you write your CCNA exam, or are you working, or you?
I gave CCNA in 2020, the latest one. Older one I already gave, but once the entire course was updated in 2020, just before the lockdown hit, right? February was the month when Cisco updated the entire curriculum. So I gave that exam at the very first one.
And also, there is one more exam which I was planning to prepare, which is called CyberOps Associate.
CyberOps, yes, that's a good thing.
And will this be a continuation for that exam, or that is completely different, right? It's based on threats and malwares.
Yeah, I'm completely aware of CyberOps. So, see, CyberOps is completely relevant to CCNA, but what they focus there would be the aspects of networking and security. So, like in CCNA, we cover networking fundamentals. There you will understand about cybersecurity operations. So, how it is relevant, your foundational networking knowledge that you will get into CCNA, it will be very crucial for you to understand how network functions before securing them. Then CyberOps also build on basically it builds on networking concepts only. So to help you to identify, analyze, and even like respond to the cyber threats, see, CyberOps will build your those networking concepts too. There are many security network jobs which require both networking as well as cybersecurity knowledge. So once you are done with CCNA, it is a very good starting point for you to before getting specialized in CyberOps. So what is your like plan? Do you want to work like a network engineer, or do you want to get into the security domain corely?
I want to, work as a SOC analyst or a malware analyst.
Amazing.
Exploring the opportunities for that, and also the required skills for that. Because
Okay, so
I believe
what all things do you still hold as a SOC analyst experience? Means for an aspirant of SOC analyst, what do you hold presently? If I may ask.
presently I'm only working on try hack me courses.
Okay, understood.
Yeah.
Okay,
Like earlier careers.
understood, understood. So I'll suggest you start with the networking basics. Okay, CCNA is very useful here. After that, go for CyberOps associate. For SOC role, CyberOps will help you out. Other than that, you can even the skills that would be needed would be the understanding of the networking protocols, then threat detection and incident response, where Splunk, QRadar things are the tools which you can use. Then a security framework knowledge is the most key important thing, right? So NIST is there, ISO 27001, that is also one of it. So you have to get understanding of that also. Along with that, Python and Bash programming, because when I appeared for Alphabet's interview, although there were some challenges through which I couldn't make to it, but in Alphabet, Bash programming was one thing which came. So Python and Bash programming is also one coolest thing for automation that you should know.
What are you doing? Like, what are you working as?
Presently, I'm working corely into the training domain now. I've left the production jobs. Now I'm working as a corporate trainer.
Okay.
Yeah. So like helping the people as a consultant, helping them out to deploy their sites towards the environment, and even training you guys so that you can also come into our environment. So I'm working presently as a link between both these spaces.
And also there are many domains like vulnerability management and all of
There
them.
are hell lot of domains presently. If I talk about CCNA, right? So we are just sitting at a shore of the sea, and just shaking our legs into the water. The entire sea is very vast.
Yeah.
Yeah.
And what about CEH? Will that be required for this? I mean, that's completely different, right?
CH is also a very useful certification for cyber ops if you want to go, because like hacking techniques is something that CH can help you out for. You can go for CH, or OSCP is also one of it. So you can go for both of them. OSCP will give you more hands-on knowledge. CH will give you more of the theoretical knowledge.
Now, how about the job opportunities for that? Like after this successful completion of the certificates, can we like confidently expect a job interview at least?
Definitely, if you have good holds over your skills also, like see, completing a training and completing a training with a proper hold on the skill, both are the different thing, right? It completely depends on different people and their caliber. I hope you agree with me, right?
Yeah, makes sense.
Correct. So how strong hold you have in your skill set, that will prove important for your securing the role. Like I even appeared for a few interviews where 12 or 13 years of experience was needed, right? But luckily you can say, or depending upon my knowledge and what exactly experience the recruiter was looking for, I tend to crack that particular thing with 5 years of experience only. So that was also one case of a few years back which I did. But after that I realized, okay, fine, if there is an experience thing there, not only the knowledge is there, there is multiple things which are required, and that's why that is called as an experience basis hiring, right? So yeah, means the more you learn, the more you'll grow. That would be the most easiest line I could suggest you, right?
As a fresher, like what do they expect? Like apart from certifications, yes, of
You
course.
should be a good learner. You should be a good learner. You should be a good listener. That is the only thing which I would suggest, right? Because see, whatever you're learning here, it is creating a base for you. Once you'll get into the company, they'll definitely give you training for 3 months, for 6 months. There are different trainings depending upon the project that you are going to get into. So you'll get trained there also. So in interviews, rather than getting to understand what you know about, they would look for what are you capable of learning to. That is one thing that most of the recruiters look onto. I'm not talking about the C grade MNCs, I'm talking about B grade and the A grade MNCs, the top MNCs, where you all would be looking for to get into, right? So there they would definitely look for a learner. Is the person a good learner? Is the person a good derivator? Whether whatever I'm communicating to the person, will he be able to understand my guide steps or my guidance and follow them exactly the way I have explained him? These are few key things which comes in the behavioral aspect of the interviews, right? So that is also one key thing that they will look. But yes, on the other hand, skills are also important. Your technical knowledge, that would be the very first priority for them. Whether you know what your domain you are jumping onto, why you are choosing that particular job role. So whenever you're going for a job, you should browse about their website, what exactly this company do, what kind of tasks that company do, what are the projects that presently they are dealing with. If you'll navigate, you'll browse, you'll get those answers also. So be prepared for any company if you are. So just navigate, understand what your company you are going into and what role has been offered. Go through the JD will also help you guys to get into that. We will also help you guys, don't worry. Urvish has already planned so many things for you guys, so don't worry about it. It will be there for you. Okay, guys. So it's the time now. This is the time to wrap up today's session. This was a day 2 of our entire session. If there is any question, I'll just wait for 1 more minute for anyone. If guys, if you have any question, please feel free to ask.
actually missed day one, and this is my first day.
Amazing. So yeah, this was first day only.
Okay.
Yeah. Day two in terms of explanations, like yesterday we were live yesterday too, so we explained everything like what we will be learning in the course, and from today onwards we have started learning the course. Okay, guys. So guys, Urvish, shall we close for now?
Yes, yes.
Amazing. So guys, that's a wrap up for day two of our live session, right? I hope you found your today's insights valuable. I would suggest everyone to stay tuned for more learning, and don't forget to like, share, and subscribe for the upcoming sessions. We'll see you all in the next one. Until then, keep exploring and keep learning. Take care. Have a nice evening, guys. Good night.
Thank you so much.